Today's episode is sponsored by the new Refrigeration differential pressure monitor from Westermeyer Industries. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace the filter? Wait too long to service the filter, and you could end up with nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The new Refrigeration RDP-01 differential pressure monitor is available now with Westermeyer Industries. To find out more, email sales@westermeyerind.com. Once again, that's sales@westermeyerind.com. Look for the new pressure differential monitor, available now.
Hi guys, welcome to the Advanced Refrigeration podcast. I'm your host, Kevin Compass. I wanted to take a quick minute to talk about one of our sponsors that make this podcast possible, and that's Parker Sporlan and the Catch-All Filter Dryer. Do you know what can reduce system efficiencies and reliability within your refrigeration system? If you answered contamination, you are correct. Sporlan Catch-All dryers have been around since 1947 and have been perfected over the years to capture water, acid, solids, debris, including sludges and varnishes. For best practices, change the Catch-All filter dryer if any of the following occurs. Initial system install, when a system is open for service or repair, when excessive pressure drop of 5 psi across the filter dryer, when the See All sight glass indicates water is present, when doing a T1-1 acid test kit says there's acid present, during a compressor burnout cleanup, and following a successful burnout cleanup. To find out more information, by downloading Bulletin 40-10 from Sporlan.com with all the Catch-All filter dryer information. Thanks, guys. Enjoy the episode.
And let's go to April 13th. Analysis. All right, so he took care of, the technician doing this store took care of this. So they were there in March, but you see no more errors. Now there's another thing you can do to ping the network. You can go back up to the network button and test all routers and nodes. Now I won't do the entire test because there's probably 100 or 200 nodes in this store. But what I can do is just here, gas cooler. Now let's go multi-deck meet. Here's the node details. And right within here, instead of going to that report, Kevin and Brett, if I go to this question mark, this shows me recent communication errors. No errors. Okay. So I can either go to that report, the MRE report, or when I'm inside the node itself, here's the communication error situation. I always go to this question mark right here, and no errors found. So that's another test that you can do.
Hold on. Is that those other numbers over there? Is that important to anything? So like if you have this type of error or this type of error, this could be this common issue or whatever?
No. If you want that detail, what you should do is go back to that MRE report, Brett. Okay, so that's just going to enumerate the amount of errors that you have. But if you want some assistance, like helpful tips on what to do, you would definitely want to go back to there. Okay.
Okay.
So while I have this highlighted, remember I could test when I was within the node. I could also test from here. So simply test node. And here it is, test OK. So I could either do a test through the node front end itself or through this report. Okay. I'm going to come back to this report. And let's go back to here. So let's see, we did the node statistics. The analyzer. This is something I think, Brett, you were asking. This is another analyzer. What this will do is give you the amount of updates. And you see right here in red, so I'm going to hit refresh. What this will do is this will tell you if a node, maybe because of high voltage interference or whatnot, has been corrupted and is talking too much. But if you see things, if you see like 20 or 30 or 40,000 updates, that's a node that's just gone off kilter. So if you're in the 1400s or the 1300s or down in single digits, that's a node that's working fine. Okay. So that when I first brought this up, that was an old report, and that might have been left there since startup, where of course you're going to get a ton of errors because everybody's violating the network with turning power on, off, connecting and disconnecting things. But you can see that this is a very tight system. So here you have the node identification, the NV name, the subsystem it's on, the elapsed time, the number of updates, and the update interval. Okay, and this is helps you find if you've got a node that's gone off the rails and is just spitting out a ridiculous amount of information. Of course, what that does, it's going to bog down the entire network because it's just putting out quadruple or quintuple the amount of communication packets that it should be doing, and then you wind up dragging the whole network down. So this is a good report to do. So this is by update interval, and then you could also look at it by NV. And again, this will give you the number of updates. Again, who, why, what, when, where. Any questions, guys, on that?
I just had a comment. So,
Yes.
I mean, one of the things you can do, if you have a numerical value being present about, how many errors that you've had, see what it is at first when you first get on the job site. Recommended that maybe you reset it and see how often the error is coming through. Monitor it for about an hour. You'll be looking over the prints and everything else, trying to figure this thing out anyway. And then basically go back and see what it is like after you had made a repair, right? So if you found weird resistances when you were checking the echelon cable, right, and you weren't getting 53 on both sides, you were getting something crazy, you fixed a certain connection, came back, reset it, and see if it's coming in and out less now, to see if you actually made an impact on the network.
Yep, good point. And it's always good. What I always do is after the stores run for 5, 7, 8, 10 days, I would always come back in remotely and do a reset because the amount of alarms, the amount of network errors and whatnot, because people have their hands all over the system. And like I said, somebody is working on something and they turn the power off to the system inadvertently, it creates all kinds of errors. The microthermal control is always gets shipped with a UPS. So if somebody turns all of the frozen food aisle off, the HMI is still going to be looking for it. So it's going to go, oh my God, where's this? So it's going to start spitting out a bunch of lost communication errors. And, and that stuff, that's normal. That happens on a startup. So good housekeeping would be, come back 7 days, 10 days, 14 days and clear all of that stuff out. And then, like Brett said, then take a look, a day later, 2 days later, and make sure that if you were having a problem, that you did solve the problem.
You could also have, one board or one section of communication that could be actually taking out the whole network. So sometimes what you would have to do at that point, and I know we've discussed this, where basically you start breaking down the network. So if you got, 4 connections that are going out into the store, and the whole store just keeps going intermittently, just on and off, as far as communication, what you can do, unplug all the communication cables, plug in number 1. Oh, wow, it's really steady. Nothing's really happening. Plug in number 2. Still running steady for the next 10, 15, 20 minutes. Plug in number 3. Oh, it all went to hell. So then basically you would unplug 3, plug 4 back in. Now you at least have 3 good networks, and now you can work on trying to figure out what on that network is causing you to, basically have your issues.
Right, and short of doing it manually, you could go up into the network tools here and then use, again, either testing all routers and nodes, which will be a little bit too long to do for this show, but that would do that for you, or doing the node statistic report would be a way of doing it. Now, I don't know if we have time for this, but I do want to show you the network quality. I guess you might be able to edit this after, but I do want to show you this. But let me do one thing. So I'm going to highlight a node here. And we did, you can see the node details. We talked about this. Now the location, your description, your neuron ID, and then again, here's all your communication errors are going to be listed here. So here, this one, since the last time it's reset, it's got a total of 890. I don't have permission to do this, but if I wanted to clean house, I could reset the counter to 0 if I'm sure I've taken care of the problem. And then again, if you're looking for most recent errors, you just hit that question mark there, and it'll tell you most recent errors. Now, let's just, if we have time, I'd like to show you this network quality, but that is going to take 5 minutes to do. So did you want to just talk freely while this is doing the test, or you want to edit out the time? You tell me, Brett, how you want to handle this.
Let's do it. Yeah, we'll talk through it.
Okay, cool. So now I'm going to do network quality. So the first thing it asks me is, do you want to reset all communication errors and nodes first? Yes. So this is going to take a little bit of a time. But what this tool does for you is it's going to look at everything. It's going to look at every node. It's going to look at communication errors, etc. So now it just reset everything to 0. And I'm going to hit the button that says Start Test. So I'm here to tell you, if you want to make a note of this, guys, we consider a very good network if you get a quality rating of 11 through 20. If you get a network quality more than 20, a 30 or a 40, then it's time to start, your detective work, like Brett was saying, and start looking for where either you have excessive resistance in a channel or a sub-channel, or you got a node that's chattering too much. So again, you want to be 11 to 20, and if you have a super tight network, you want to be from 0 to 10. The closer you get to 0 on the test, is excellent. So anything from 0 to 10 we consider to be an excellent, very, very tight network. So right now it's thinking. That's why we got the spinning blue wheel here, and it's probably going to ask me if I want to do a bunch of clearances. And then you'll see the clock. Okay, the network quality test will not be accurate. Reset any node. So I want to do yes. And you see now it's starting down. So this will take 5 minutes. So I'm going to throw it back to you. And anything you want to get out there, anything that I could explain while this is going on, I'll be glad to do that.
So Charlie, on the actual nodes, so say you're like troubleshooting a node, you got one offline.
Mm-hmm. Yeah.
Oh, his internet.
Uh-oh. So after we do this test, maybe I'll go back to a node and just open the node itself up, Brett, and hopefully Kev could get back on, and maybe we can do some virtual troubleshooting of a node right within the icon itself.
So how many nodes are you limited per either branch of the line or on the whole system entirely?
Okay. The number on the whole system is so large, I would have to look it up, Brett. But again, the network, let's say Bible by echelon is this. You're allowed to have, as far as cable length is concerned, 1,640 feet. And within that 1,640 feet, if they're simple nodes like an MT500, 508, 512, you can have a total of 64. We round the number down, we just say 60. If they're compound nodes like the case controller, we say 50 because they're communicating so much when they're a compound node. Now, if you need that segment to be bigger, what you can do in Microthermal, and I should have said that when I had the PowerPoint up, you can start a channel with a router. You can go 1,600 feet for 64 nodes. Then I can put an echelon repeater, and then I can go another 1,640 feet and another 50 compound or another 60 simple nodes. And I can have as many channels. There is a maximum. I don't recall what that number is, but I've never, ever, ever gotten close to it. Ever. It's a large number. I'm sorry that I don't know that number off the top of my head.
You're fine. Kev, go ahead and finish your question. I'm sorry. You cut out.
Yeah, sorry, my crappy internet went out again. So say you have one board, Charlie, just for everybody. Say you have one board offline, and you're going through it. It's got power. You can't get it online. Where do you go next with it, with microthermal?
Okay, all right. So if I've tested and I've got power, if I've done the network test, and I've done the the communication test. Actually, what I would do at that point, we keep plenty in stock. I would pull that node out and replace it. I wouldn't go any further than that. I really don't have that happen very often, but if I was doing the full microthermal class and it was a simple 508 board, there are test points where you can check, okay, I've got 24 volts coming into the board. Now, some things like simple switches and thermistors, they need the 5-volt circuit. So there's a point on the board for ground and another 5-volt test point, and you can see, do I have a 5-volt circuit? Yes or no? Then transducers and complex devices like a combined temperature and RH might need 15 volts. There are other points where, again, ground and 15 volts, and you can make sure that you do in fact have 15 volts present on the circuit that is supposed to power those complex devices. If it is a combo board that has relays, there are momentary switches that you can toggle back and forth to physically hear the switch make or break on the control itself. And if you're close enough, you can hear the that's a pilot relay. Then you can hear either a big relay make or break, or either a fan come on or off, or a compressor come on and off based on the action of the momentary switch. So I would make sure that I have power. I would then make sure that it's not a violation in terms of the board wasn't programmed completely. So I would hit the reset button, which is momentarily takes the power away and wipes the temporary memory, and then I would either reprogram it or send the configuration back to the node. Sometimes it was just a broken install. Okay, so if you've done everything that I said, you tested the voltage, you've done the internal node test, you've looked at the recent error reports, you've done the physical tests on the relays, and then you've you did a reset on the board, and you sent the configuration again, and the node still goes offline, then I would replace that node, Kev.
Simple enough.
Okay, it looks like we're getting close. We should. The test is over, so we should get a value on this shortly.
So
again, go ahead.
Sorry. Real quick before I forget. So we were talking about voltages. The reason, guys, why that's really important is, most boards have a certain range that they can be high and low. It's important to pay attention to that, because if it does go lower than what it's supposed to, a lot of times you'll start having draws on, basically your network, because it'll be too low. Or if you have an input board, you could have sporadic numbers reading on there, because it's basically changing your voltage, which is changing, the reading that it's supposed to be getting back to the controller for your temperatures. So I've seen a lot of times where, it'll say that it's supposed to have a 240 transformer, but, maybe they messed up and it's supposed to be, 208. Well, basically that's going to throw your voltage off. Especially most of the time you'll see this in the peak of summer, because the hotter it gets outside, more people are turning on the air conditioning. We're just putting draw on the voltage on the grid. and basically your voltage is all the way in the toilet, causing your any of your controls or anything to malfunction. What's the lowest voltage that Microthermal can run on their boards?
It's plus or minus 5%. No more, no less.
Okay.
Yeah, plus or minus 5%. Now, this is an incredibly tight network, one of the best that I've seen. So, remember I said that 11 to 20 is very good and 1 to 10 is excellent. This is 1.3. So, that means the actual physical wiring itself, all of the connections, all of the amount of errors since this store has been running. This is one of the best stores that I've seen. 1.3. It's as close to zero as I've ever seen. So this is a very, very tight network. So you would expect no loss of any nodes, no loss of any information, nodes not dropping off and disappearing. This is a tight store with a tight network.
You need to find me a store that looks really crappy as far as the network. I was just interested on all the numbers and how bad it was going to be, right?
Oh, I've seen a store recently where the electrician daisy chained all the rooftops, and I'm talking slow. Like, as soon as you unplugged all the rooftops, I mean, Alliance would run fast. It was speedy. As soon as you plugged the rooftops back in, everything was just slow.
Yeah,
and
yeah,
the
that's
network was terrible.
Yep. What you should do is just come up with a drop to the roof, and then if there's 6 rooftops, just make a 6-leg spider and just pick each one up individually. He probably just did, like you said, Kevin. He probably just did one big ass daisy chain from one to another. There was probably tons of extra cable and whatnot. If you put a network segment in or a channel in and it bogs everything down, that's absolutely a violation, and that's a dead giveaway. So that was a good heads up if you call it that. But what you wind up doing? Did you have to have him rewire the network over there?
Well, he didn't end up doing it. I ended up doing it.
Okay.
They were gone by then, so it became the startup guy's problem.
What were the numbers before and after, Kev?
To be honest, I didn't really check. I just knew that that was the last part of the job. So we just knew as soon as we brought the HVAC online, it was nothing but problems. So I didn't really check that at that point because we already knew there was an issue, and we saw the daisy chains. So right away we knew we had to start. We had to move a bunch of them around. We ended up having to star a couple. And it got a lot better after we made a couple stars and got rid of the big part of the daisy chain at the front of the store. It got a lot better.
There's one thing that I want to show you, which is pretty cool. Let's see, do we have one on this store? We go back to here, something we call an MPC. I'm going to open this up for you. And this is not really network, but what this does is this allows you to take one of our standard boards and jailbreak it. So you see the node type is a 508. Okay, so that has 8. All of our 500 boards have 8 universal inputs, okay? And then the number 8 or 4 or 12, that tells you the amount of relays that are on here. So here's what's being input to the board. Universal 1, Universal 3, all of these are unconfigured. So this looks like it's the refrigeration trailer out back, and we're simply, taking the temperature. But this is the cool part right here is the network. What this does is it visualizes for you instead of all of the ones and zeros and getting into C++, what you do is from these palettes, you drop down. Okay, so here's digital input 1. It's a switch. It's going to NVO. It's also going to the timer. And then out of the timer, it's going to go to DO7 and DO8. And he did a good job here. Alarm silence. If the button is pressed, DO8 will open NC contacts for the refrigeration alarm board relay number 1. If a new alarm comes in the board, relay will pulse and will reset the silence. And it looks here's a gas cooler water drain. So this is part of Microthermal that actually lets you get in and write your own program. And you do it, again, I use that term GUI, graphic user interface. What you do is you're pulling down what you need, an NVI, an NVO, or whatnot. Do I need a PID? Do I need a timer? Do I need a sequencer? And if you can think it and draw it on a pad, then you do it on this palette here. And this is how you do a custom program of a Microthermal board using the MPC, which allows you to, we try to think of everything off the shelf for boards. Okay, you want it to be a gas cooler, you want it to be a condenser, you want it to do a chiller skid, but what this does, it opens it up or jailbreaks it, for lack of a better term, and you can do custom programming of a 500 or a 700 through the MPC.
Do they have them for the 7? Can you do MPTs in the 7?
Yeah. We got it now. Yeah.
Oh,
Yeah.
Beautiful. Yeah, I was waiting for that. That's going to be real nice.
So,
Can you have multiple boards in a train on a 700 board?
yes, they all have to start with a 722F. And that's the main microcomputer, and I can have, depending upon the utilization, a total of another 10 nodes plugged into that lead 722F.
Oh, see that's awesome. I mean,
Now the one thing that Kev, you and I discussed this, when it comes to racks. It's not a limitation. It's a rule that we put onto ourselves, especially with CO2. There are certain inputs for oil, for temperature, for pressure that we want absolutely to be instantaneous. So they have to. This is just the way the engineers want it. They have to land directly to that board. We don't want to take it as a network broadcast, because no matter how fast the network is, there is still a lag time when it's a broadcast variable rather than a pressure transducer that's wired directly to the board. So I just want to make sure everybody that listens to the podcast knows about that when it comes to controlling a rack, especially a CO2 rack. Back pressure, head pressure, gas cooler, outside ambient or whatnot. There are certain things that have to be home run, hardwired landed to that MT700 that's controlling the rack or the gas cooler, because we don't want not even a half a second delay in that information being available to the node. Other than that, you can broadcast. So like if I have a multi-deck with a case controller and I want it to be smarter, and I wanted to know what is happening to the inside relative humidity and the inside temperature, if it gets it at a quarter of a second or a half a second, or God forbid 1 second lag because it's a broadcast network variable, that's not going to foul up the case controller at all if it's a little bit slow getting that broadcast information. But my guys in engineering feel that they don't want any type of a lag when it comes to the nodes that are controlling a CO2 rack and a gas cooler. They want it to be real time, landed directly to that train. So they all start off with a 722F, and you can mix and match. You can have input boards, you can have valve boards, you can have combination where it's inputs on the bottom and relays on the top. Where the 500 series kind of locked you in, there wasn't a lot of flexibility. With the 700, you have much more flexibility because that 722F, that brain is so much more powerful than the micro computer that was on the original 500 series.
Charlie? I would love to get you on again, Charlie, just to go over like the 700 series boards.
Okay, sure.
Their programming, and then also we've had like a ton of requests for you guys to like come on and go over MPCs, like just like a light build how to build an MPC, like go over the program. I mean, guys have been asking for like nonstop.
Yeah, well, what I'd like to do, especially with the MPC, is maybe get somebody like Michael Morissette,
Yep.
one of our resident geniuses up at Montreal, the guys that write MPCs all day. You know what I'm saying? He would be I know how to apply them, but to have somebody really, give you a 101 on how to do an MPC, yeah, we can work something like that out, no problem.
Charlie,
Yeah,
how do you give me the software for the to make all those logic statements so I could practice that?
I can send it to you. You can download it. There's a demo version of Micro Thermo. It just comes on a regular zip drive. So what you can do is just anybody listen, send me an email, and then I'll get you. We're up to I think version 8.3 on the device, and it's going to do about 90% of what you can do in a real site. So you can build a rack, you can drop case controllers and whatnot, and it functions almost like a real site. So yeah, that's our demo program. And just make a note, it's real simple. The user ID is demo, DEMO, and the password is demo, DEMO. Yep, and it's on a little zip drive. We send it to you. It's got to be loaded on a Windows device, though, Brett. It's not going to work on an Apple computer or whatnot. It's a Windows driven application, so it's got to be on a laptop. I'd prefer Windows 10 because the version 8 and higher is so much powerful. Windows 7 was okay for like version 6, version 7, but hopefully you got a version 8, a Windows 10 laptop. It'll work the best on that.
Hey guys, I want to take a break and talk about Westermeyer, one of our other sponsors. Today's episode is sponsored by Westermeyer Industries, the leader in oil management and pressure vessels for the commercial refrigeration industry.
Well, that's everything that I can think of. Is there anything in terms of troubleshooting that you were looking for that I didn't touch base on tonight?
no, I think you did a great job of the network stuff. I would love to get you back on and maybe go over the 700 series and 500 series stuff, and then eventually break out into some of the MPC stuff. I think guys will love that, and I think it'd be pretty good.
Yeah, yeah. We could again. It may not have to go as long as this one, but we could do one on just 500 hardware. Okay, I can talk about those test points that we talked about earlier, and the ins and outs. How many analog outputs, how many inputs, etc. And then we can do another show for 20 or 30 minutes just on the 700. Maybe again try to what I can do. Let's see here. Let me go to the rack. Let me see. Let me open this up. See, that's what the 700 looks like now, and it's so much nicer. You'd had to be use microthermal all the day to every day know where all of the information was in the 500. But we've again, you go to the library stack. I call it the stack of knowledge. So anything about the rack, the discharge group, the suction group, one suction group 2, you would find from this stack here. Your configuration. So everything you needed to know about the configuration. But the cool thing that I wanted to tell you is with the 700, this is what I like. You get an actual, a virtual picture. So it starts with the 722. So here, this is VFD speed. VFD speed. This is pressure. This is a simple switch. So you just hit this arrow. So it looks like we've got the 722. We got a 784. We got another 784, and we got another 784. So if you see green, that means it's available. But you see how this Kev, it's mix and match. I got a switch next to a temperature. I could have then a pressure. You can mix and match it and purpose this where you really didn't have this kind of flexibility and liberty with the 500, with the 700 system. I mean, here, pressure, temperature, switch. Okay, feedback of the drive. So again, it all starts with the 722, which is a super powerful brain, and this has another 1, 2, 3. So I can have a total of the brain and another 10 nodes plugged into it, if I needed to.
Can you do the same thing you're doing there, except for showing me the nodes for the inlet pressure for the inlet pressure regulator for the flash tank?
Hold on. So let's see, where do we have that? Let me get out of here.
So that's going to be a 700 something, right?
Oh, yeah. So let me find out where they got that. So
they were pretty good.
Oh, here it is. Here's primary throttle and FGB control.
Here we go. Let's check it out.
Yeah, they work pretty good. We did like 2 or 3 stores with them, Costco's with them. I mean, they.
Yep. So this is the 700. It's a 2-valve controller. So this one just takes a special brain and a special controller. So not only, so we said, hey guys, now that you did this for CO2, you could do other things. What do you mean? I said, well, how about if I had a CDS before and after, just a regular receiver? Or how about if I had an A8 or A9? So now get this, we make a motorized head that you can retrofit onto an A8 and A9. And back from my days when I was strictly a mechanical guy, I would do classes and, Charlie, wait a minute. Which one do I do? Do I do the A8 first, or do I do the A9 first? So to take all that mystery out of how do you set those valves out, you put a motor on the 8 and then A8 and A9, and then you use the 2-valve controller to feather. One is a holdback valve and one is the receiver controller, just to control the receiver in a standard system. So it's cool. So on this, again, you got the question mark here, and again, help on this system page. So anything you want to know of what this is doing is on there for the question. So here's your inputs. All right, so we have pressure, and here's the model number of the pressure transducer we're using. Here's an onboard diagram, so you don't have to run and find a catalog. So your common and your shield are together, and then your signal is coming in on the white, and your power is coming in on the red. And the cool thing we did on the 700 series, one thing that a lot of people are concerned about, and when I do the hardware class, the 500 boards had to be a center tap transformer. They had to be, because of the way they split the 5 volt and the 15 volt circuit up. The good thing about the 700 series, you look at the VA value for each, for the brain and each one of the nodes. Just make sure your transformer can handle the train, but it's just the standard transformer now. It does not have to be a center tap transformer. And that might not sound like a lot, but brother, go try to find a center tap transformer in the United States when you need one. That's bit me in the butt. I can't tell you how many times if somebody smokes one of the older 500 boards, they can't be fed with a regular transformer. Okay.
Right. What tab we at? We at outputs right now, or?
No, we're on the inputs. So here's I've got my pressure, I got my temperature, I've got now see, this is bound, so this is coming in from the network. T08, that's direct, and that's just an orange lead. T21, that's another 10K2 orange lead. So that's the inputs, and let's see, what are my outputs? Okay, so it's a Sporlan. Now there's other valves that we look. See, we're agnostic. We can use an Alco, we can use a Danfoss, or we can use a Sporlan. So this store has a GC30. It's programmed radius. What does that mean? The inlet is coming on the radius of the port. And they used an SDR4 here for this valve, for valve 2. So again, Sporlan or the other manufacturers that I told you about. This happens to be an SD4, and here's the current percent open, and if I was going to override it, I could do it right from here, but yeah, here's the initialization, here's the LAN information, here's the drive information, and same thing over here. General, limitations, initializations. So this is the only one, guys, that looks like this, because this is a specialized valve. What this does is it controls two valves concurrently and simultaneously, so they feather back and forth. So this window is different than any of our other 700 windows because of the specific purpose of this combination here. Again, strictly we designed this to control the flash gas bypass valve and the drop lay coming out of the gas cooler, and they got to work in tandem. Just to close this picture, so what we have going here is, again, if the CO2 has gone past the critical point and I've got a supercritical undefined fluid, then I have to make sure that I can have enough of a pressure drop here so that I can urge that CO2 to come back to a liquid state over here, I'm sorry, and then again it's got another valve that bleeds off to the low temp suction. So through a suction and through the drop, we're always trying to maintain as close to 100% liquid CO2 in the flash gas bypass at all time. And again, I notice with CO2 systems, you're doing well if you can have 2 or 3 or 4 degrees of subcooling. I've not seen one yet where you can get 8, 10, or 12 degrees of subcooling. So you got to be careful with your piping and whatnot to make sure that you've got 100% liquid CO2 getting out to the store. So yeah, that combination of those two valves by that controller, that's where a lot of the magic happens in a transcritical CO2 system.
Kevin, how you probably looked at a bunch of the graphs for these. You've always said that the 326 controller has a decent program in it, but normally, if you get it right off the shelf, you're looking like a 40 or 50 pound differential between the flash tank and basically the high and the low for the set point. What have you seen when it's being controlled through Microthermal?
I mean, it's the same way until you tune it. I mean, after you tune it, the Microthermal one's just as good as the Danfoss one. It doesn't matter what it is. The stock settings never work. Everything has to be tuned, and that's the beauty about Microthermal. You have more tuning set points in the Microthermal in that 2-valve controller than you do the Danfoss. So you have a little bit more flexibility with it, and it's a little nicer in that sense. Mm-hmm. But Danfoss is easier canned. I mean, but you get more flexibility with programming and tuning on the Microthermal controller. Like I was able to get the receiver pressure at like an 8 pound swing max, which is pretty good.
Yeah.
With the 2-valve controller, and that's with me having limited time on it, messing around with it.
Where is that in the settings? Like if Charlie goes back to that, where would that be? That obviously not inputs or outputs. Is that more in the detailed, or where is that?
It's in the PID settings.
Oh, okay.
Get out of here and let me go to, we may have to blow up into this, and gas cooler.
I'm excited here because I don't get to go.
Yeah, yep. On your jobs, have they been in an MPC, Kevin? Where the PIDs for the gas cooler was? Where did you find them in the jobs that you were working on?
All mine were in the 700 boards.
Uh-huh.
Like for the
okay. So it's going to be in the block diagram here, the way this guy did it.
Yeah, I've never seen them in the block diagrams.
Okay.
All of ours were actually in the actual 700 board. You would go into the 700 board, and all the settings were inside of there.
Yeah.
Once you opened up the little three lines, and you actually went into the setup of it, you could change like the throttle range, the flash gas
Yep.
bypass, uh, minimum percentage, and all that stuff.
Okay. And that was probably. Is it all right to mention the manufacturer? That was probably a Hill store.
Zero zone.
Oh, Zero Zone does it the same way too. Okay, this is an LMP store, and the reason they jailbreak that with an MPC is because they're doing other things. You see this here; they do actually liquid injection. They do heat exchangers, so they add a couple of extra bells and whistles, more than I've seen on other stores. So that's probably why they did the jailbreak, and they have that MPC on the gas cooler control rather than something off the shelf. So again, it looks like what they did on the gas cooler here is they actually wrote a custom program for that.
Yeah, see, mine were all Costco's, and
Yeah,
you guys
yep,
and
yeah, it was,
Microthermal had
yep, it's off the
100%.
shelf. Yep,
Yeah, 100% control. It was however you guys wanted to control it. You guys were
yeah.
the complete control
Yep.
integrated.
Yep.
So
Yeah, I wish I could go into a Costco, but they don't like me to do that, so I can't do that. But Kevin brings up a good point. Any store, especially with Microthermo, it will run as good as you set it up. So an easy way to explain that. I'm going to open up a case controller. And let's just go to this me case here. And it's programmed off the shelf by my integrator, and that's as close as he can figure to make this board as smart as you want it to be. But if you have the time and the money on the job, the first thing you want to do to see, okay, how well is this controlling, go to the graph. That's pretty damn good. Let me blow this up. I wasn't expecting something as tight as that. The blue is the set point, and the green is the actual temperature. So you see this case controller is working tight. If somebody doesn't do their due diligence, this can be super spiky and all over the place. But again, what are some of the things I would do to tighten up? I would go into graphs, and I would go into valve position. So let's go percent valve open. So you see that? Look at that. This guy, whoever is doing this store, they got this brother on the money. So I close for defrost. I open wide right after defrost, and I drop like a rock as far as I can, and then I'm modulating right around 40%. So stay with me here. So I'm going to go to control. And all right, he's got the base open of 30%. I might say it should be 40, but with those linear graphs, and the refrigeration range is 30 times 2, so the maximum this would ever go is 60. And again, this is all going back to the graph again, so let's go back to the valve percent open. Um, you know, what they're doing for regular refrigeration is they're noticing the valve never really has to go much beyond here. Your average is 37.3. Okay, so why let the valve go 100% open if it doesn't need to go 100% open? Then the other thing you do is you go to your superheat, and that's pretty steady superheat. Right there, that's plus or minus. Now again, with CO2, don't be alarmed. That might be a little bit higher than what you would expect, but with CO2 control, as far as superheat is concerned, okay, it's really working in the background to prevent flood back. But as far as the configuration is concerned, it's temperature control priority with superheat as a backup. So that's why you might see, superheats that are a little bit higher than one would imagine. But if you do your job right with Microthermo, so this is a 2 temperature, this has got a set 1 and a set 2, but that's the kind of graph you want to see. If you see a graph that's all kinds of spiky, then you haven't done your job. So you should see your peak up like this on defrost, and once I go back into refrigeration, it should drop like a rock, and that's the way it should run. Totally linear, right on top of your set point.
And the more linear you get all those graphs, the better off all the rest of the graphs are going to be as far as all your pressure and stuff. Sorry,
Right,
Kevin.
because you're right, Brett, this is compound. So imagine 150 nodes in the store, right? If they're all over the place, then your load coming back to the rack is going to be bouncing all over the rack place. So now your rack is going to be unstable. So that's the key. Start at the evaporator. Get that stabilized. Don't give it an ounce more refrigerant than it needs to do its job. And with CO2, I'm going to say 99% of the stores I've done, it's all been temperature control with superheat limit. And I mean, these are beautiful graphs. That's exactly what you want to see. This is getting your money's worth out of electronic controls. If you pull up a graph and it's haywire and it looks like a mountain chain with a bunch of ridiculous spikes all over the place, you got to go in and you just like Kevin said, there's off the shelf. We make our best scientific estimate of where it should run, but you should come back and tune things up so that it runs like a top. And then once it's run like a top, it's up to you. We do have customers that once they've done a run of about 6 months, they really are strict and they lock the system down. And instead of giving configuration, they may only give maintenance permission. And that will limit a lot. You see how this pallet went away? That'll limit a lot of what you can do at this store. Again, it's the end user store, but what they want to do is they want to lock down that performance envelope so that it doesn't drift away over time, and then the store becomes an energy hog.
Yeah, plain and simple. That 700 series case controller is probably one of the best case controllers out there, if not the best. Like that controls cases so much tighter than anything I've seen in all the abilities you have to tune everything.
Yeah, and Kevin, and the reason for that is, when you open it up, see what I did? You always have to remember, it looks like it's going to, I always try to be in configuration if it allows me, but your system information has to be set up correct. Your configuration has to be set up correct. You got to double check your inputs and outputs. But the reason it gets to be so smart is there's a valve setting. Let me put my... Okay, there's a valve setting. Okay, so again, here's the base value for this case. It's 20, 2.5 times 20. So the maximum under refrigeration, not after defrost, under normal refrigeration, this valve will never go over 50%. Then there's a superheat algorithm. There's a pull down algorithm. There's a temperature control algorithm. There's an environmental correction. Now they're not using that because I think this could be a POS. There's defrost algorithm. So you have all of these algorithms set up. And again, that's how we get those case controllers to be so tight, because there's so many correction factors running concurrently in the control. That's why we're able to get graphs. Let's just take a look at another one. This is looks like frozen food, and we'll take a look at that. Oh, jeez. I got to tell you, man, that's a thing of beauty right there. I mean, I'll zoom it in. When I first got into this business 40 years ago, I thought you could only do laboratory control that tight, but you can't even see the difference between the blue and the green line because they're right on top of each other. That's how tight it is. So here's another cool thing you could do, trend graphs. So somebody's already set this up. So here's your control temperature, and here's your circuit control temperature, calls for it, and you can build a total of 7 graphs within any of our nodes, and then you can save it in history. And then if you've got a bad actor and you need to come back to the store in another week or another month, you don't have to recreate all of these graphs again. You've just got to say you've got it saved in history, and you pull it up when you have to come back to the store and troubleshoot. It's already there for you. Well, guys, thanks a lot for spending the time with me. I really appreciate it.
No, I appreciate you coming on, man. I've I love when we do podcasts like these because I learn so much. You know, I like you said before, I would love to have you on again. Talking about different aspects of some of the different controllers, some of the other
Sure.
troubleshooting with that.
Hmm.
Kevin, did you have anything else?
I think that's it for tonight. I mean, this is a good one. This is going to end up being 2 episodes. I mean, we got a lot
Yeah,
of
for
time
sure.
down to this. So I would love to have you on again, Charlie, and
Sure.
maybe we could set up something with Michael and do the NPC stuff. And
Yep.
I mean, I think that'd be great. And I mean, you guys are going to get a lot of experience out of this. So I really appreciate you taking the time and talking with us.
My pleasure. Thanks for the invite. I appreciate it.
Before I forget, guys, there is a document out there, best wiring practices for Microthermal. It shows you how things should be wired, the rules of thumb, a lot of the stuff that Charlie went over. But just be mindful that that document does exist. And if I can, I'll try to put it on the Advanced Refrigeration podcast Facebook group. I'll put a link to that file on there so you guys can read through that if you like.
Awesome. That's a great point. We do have one on wiring, and we do have a bulletin on network architecture. So that's available. I could get you the bulletin number on that too.
Yeah, absolutely.
Cool.
Beautiful. All right, guys. Thanks for listening, and thanks for coming on, Charlie. I appreciate it.
My pleasure, guys. Thanks for inviting me.
All right. Have a good night, guys.
All right. Take good care.
All right, bye.